All right, today what we're going to be working on is linear relationships and seeing how multiple representations work with a given scenario. So the scenario we have today is a pumpkin at a pumpkin patch weighs 4.5 pounds and costs $1.35. There was a fee of $2 to get in. How much will buying a 1 pound pumpkin cost? So what's happening here? Well, we're going pumpkin shopping. We know that we are finding a total. And what are those keywords that are going to help us know that? Well, we know there's a cost, we know there's a fee, and we're looking to see how much we are going to buy. So already we know there's things like adding and an increase per poundage. So the next step is going to be to make our table. So when we look at the table, it's already given us some values, and we don't know what our process is yet. So we're going to get there. But if I don't buy a pumpkin, I don't know what I'm multiplying it by. I don't know what x is, but I can say 0 times anything is that number, right? Or 0. And I know there's a fee to get in, and that's $2. So it's going to cost me $2 to get in, even if I don't buy a pumpkin. So at the top, I know I'm adding on that $2 because it's a one-time fee. Now I need to figure out how much it is for each of those pumpkins, so that way I know what I'm multiplying by for each pound. So I'm going to take my cost. It's $1.35. And that pumpkin was 4.5 pounds. So we need to change that to a decimal. So we'll do 4.5. We know we can't keep that decimal out here. So we're going to move that on over, bring it on up. Now I have 45 on the outside and clean that up a little bit. And I have 135 on the inside. Well, I can see that 45 is going to have to go into this a few times. 4 is close to 13. I'm going to see if 45 times 2 works. And that gives me 90, not quite there. Let's do 45 times 3. And that gives me 135. Well, that means that it costs me 30 cents for each pound. So I know that it is going to be 0.3 times however many pounds I buy. So here I have 0.3 times 1 pound pumpkin. Here I have 0.3 times a 4.5 pound pumpkin, plus our entry fees, of course, and 0.3 times a 10-pound pumpkin, plus our entry fee. So here, if I multiply that out, I'm going to have a $2.30 cost. Here, we are going to have a $3.35 cost, and down here, we're going to have $5. All I did is solve out that middle column to find out how much each pumpkin would weigh. We're going to take that and build our graph. And now this particular case, I already had a line established for you, and we're just going to match our points that we had on our graph. So these are ordered pairs. We're going to go 0 to 2. So we start at the origin and go up to the number 2, and there's a dot there. 1 and 230. So I'm going to go, here's 1, 2, 3, 4, 5. So we're counting by ones. 1, 230, just slightly more than that $2 mark. And I'm going to skip over to 4.5. So here's our 4. Here's 5. So I'm going to go in the middle, 4.5. This says it's 3, so I'm going 1, 2, 3, and a little bit more. So that works. And our last one that we did was $10. Our 10-pound pumpkin is a $5 cost, so 10 up to 5. So if you build your table first, you will then be able to find the graph that matches, because you will typically be given a variety of graphs to look at. Our next one is to write the equation. Well, our process table helped us with that. It was any given total was found by multiplying 30 cents per pound, and pound is our x because that's the thing that is independent. Our total cost, which is y, depends on that. Plus we had to pay to get in, so it's plus $2. So we just found that right here, our unit rate for 1 pound is our x, and our total cost is our y. And the last one, that means that a person will spend 0.30 dollars or 30 cents on a pumpkin, plus $2 to get in per pound on a pumpkin to get in. Now you're going to be practicing these kinds of things on your daily work. You will be given a table to fill in, a graph to plot your dots on, and a slide in which you will be putting in your equation.